Hello dear children, welcome to the first video for the lesson Electricity and Circuits. In this video, we will be talking about what electricity is made up of. We'll also be discussing the difference between static electricity and dynamic electricity, otherwise known as the electric current. We'll talk about the primary sources of electricity, which can be both renewable as well as non-renewable. We'll also discuss the working of an electric bulb. So before we get into the lesson, let's look at some giants in the field of electricity, some very important scientists, some very important people who have contributed to the field of electricity. As you all know, electricity was first defined or discovered in a very special way by Benjamin Franklin. So Benjamin Franklin did the very famous kite experiment by which he actually established that lightning is made up of electric current which can actually move if it is given a pathway to move through. So that is what Benjamin Franklin established. Then comes William Gilbert. William Gilbert is the person who established that the earth has actually got two magnetic poles, a north pole and a south pole. Michael Faraday is known as the father of electromagnetism. He is one who established the relationship between electricity and magnetism. And then comes Alessandro Volta. Alessandro Volta is the person who discovered the first electric battery. So until then, it was thought that electricity is always something that flows or that is something that is present naturally. But then Alessandro Volta showed that electricity can be stored in a chemical form. So he's actually the inventor of the first electric cell. Then comes Hans Christian Ørsted. Hans Christian Ørsted established that there is a relationship between electricity and magnetism, and there is an electric field and a magnetic field, and their directions are also interlinked, about which you will learn in higher classes. But Hans Christian Ørsted's contribution to the field of electricity was also of great significance. Then comes Thomas Edison. Thomas Edison is otherwise known as the inventor of the first commercial light bulb. So even though there were many other inventors of the bulb, which happened parallelly across the world, Thomas Edison's version of the light bulb was the one that was suitable for commercial use and was mass produced, and which turned around the lives of millions of people. So who discovered electricity? Well, we know that electricity was always naturally present. Whenever we rub two objects together, something known as static electricity develops. So the Greeks in 600 BC had come across or experienced static electricity when they rubbed amber and fur. Amber is like an orange colored natural substance. It's the sap of a plant which when it hardens it becomes a solid. So when amber and fur are rubbed against each other, they develop charges which then can be used to attract straw. Pretty similar to the way in which when you rub a rubber balloon against your hair, you can use it to stick the balloon on the wall or to attract pieces of paper. The same science works here. So Thales, the Greek philosopher, is the one who discovered electricity. Probably is the one who first wrote about it or talked about it. Persians had even made an ancient battery which could be used for light. So it was sort of like an electric battery, right? So electricus, the word electricus itself comes from like amber. So amber is this orange colored stuff that the Greeks used to develop static electricity, and electricus comes from the words like amber. So what is electricity? So, as we all know, electricity is also a form of energy. And the most fabulous thing about electricity is that we can convert it into other forms of energy. We can transform it into other forms of energy. So, we can essentially use electric energy to run our devices, to move our vehicles, and so on and so forth. Where does electricity come from? It comes mainly from two sources. That is the power stations, which supply a lot of electricity, because electricity generated in these power stations by various means, and therefore from the power stations electricity can be transported using cables, and it can be used for in electric appliances in industries as well as homes. Electricity can also be stored in small quantities using electric cells or batteries in our homes, as you are very well familiar with. You do not use electricity from a power station to run your remote. Rather, you would use an electric cell or a battery to run the remote. So it supplies a little bit of electricity. It is portable. You can carry it from place to place. So you can use your devices in an unplugged form using electric cells, and they are pretty safe to handle too, because they have only very less amount of electricity in them as compared to the direct power that we get through our switches. So where does electricity come from? The primary source of fuel from where electricity is generated in power stations can either be renewable energy or non-renewable energy. You are already familiar with the concept of renewable and non-renewable energy resources. Renewable energy resources can go on and on indefinitely because they are very quickly replaced. Non-renewable energy are present only in limited quantities, and therefore they cannot be quickly replaced, and if we use too much of them we can quickly run out of them. Also, we have this problem that non-renewable energy resources, when we generate heat to convert them into electric energy in power stations, they also generate a lot of pollution, which is not so great for our environment, for our world. So renewable as well as non-renewable energy sources can be converted into electricity. So what is electricity then? Electricity is not a primary energy source, but it is a secondary energy source which we can get. We generate electricity from renewable as well as non-renewable energy sources, which are primary. I hope this is clear. So what is an electric current then? Let's take a look. So how does an electric appliance work when you plug in a light bulb? How does it work? It happens because of the flow of electrons or charges, basically positive or negative charges flow through the uh, cables used through the power station. So this is what allows your electric appliances to work. The path along which the electric current moves is called as an electric circuit. An electric circuit always runs in both ways because it has to be a closed circuit for electric current to work. What is an electric current again? Let's take a look. It's a flow of charges, and it can be positive or a negative charge that we're talking about. So even though conventionally, we think that the charges are electrons and they would flow from the negative terminal to the positive terminal, conventionally it is believed that we have considered that the flow of electricity when we connect it to a battery is always from the positive terminal to the negative terminal. So in the opposite direction as shown in this by the arrows in this picture. An electric circuit would consist of a power source, which can be an electric cell, conducting wires, which should be, of course, made of conductors like copper or silver or other metals, and a device. So an electric current is the rate of flow of electric charges, positive or negative, in a circuit. Electric charges can either be positive or negative, and when these charges flow in a circuit, a current is produced. How does electricity flow? The battery in the circuit is what gives energy to the electrons. So the battery has chemical energy stored in them, and as soon as that energy gets an output in the way of a conducting wire in a closed circuit, those electrons are pushed out of the battery, the charges are pushed out of the battery, and they make their way all around the circuit to the other terminal, from negative terminal of the cell round the circuit back to the positive terminal of the cell. So electricity can be used to transform electrical energy. Electrical energy is transformed to what form in a table fan? To mechanical energy. So the byproducts or the unwanted products in this process is heat and sound energy. When we talk about electric motor, electrical energy is converted to mechanical energy again, and the byproducts, which are the unwanted products, are heat and sound energy. So you can see that in any of the energy transformations, there is always a wastage of energy in the form of heat and sound. So this is not something that we can control, but it happens that whenever electricity is transformed, some of it is wasted because of friction in the form of heat and sound. Then comes television. Electrical energy is converted to light energy and sound energy using a television. Again, when you touch a television, you can feel that it is hot because there is also the production of heat energy in this transformation. Then comes a light bulb. Here, electrical energy is converted to light energy, but heat energy is an unwanted byproduct. Look at this process. It shows the process of electroplating. So this is a process in which the electrical energy is actually used to drive some chemical reactions. What is happening over here is that we are using the chemical reaction to coat the spoon with silver, with a coating of silver. So this is called as the transformation of electrical energy to chemical energy, and the byproduct of the same is again heat energy. There are certain symbols which are used conventionally to show the different parts of an electric circuit, and you have to learn about 4 of these symbols. An electric cell is indicated by a short line and a long line. The short line indicates the negative terminal and the long line indicates the positive terminal. Batteries are nothing but cells which are arranged in series one after the other in such a way that the positive terminal of one is in contact with the negative terminal of the other, or vice versa. And this is the way it is represented. An electric light bulb is represented by this symbol over here, and a switch is represented like this. If the switch is open, you show a gap or a break in the circuit. If the switch is closed, you can see that it is closed. The circuit is closed and there will be a flow of charges. So the electric circuits are made up of electrical components, which are nothing but the light bulb or the device, the conducting wires, and the electric cell. And it has to be a closed circuit for charges to flow. An electric current flows only when there is, first of all, a source of electric energy, which should be the electric cell, and a closed circuit or an unbroken path, which is very, very important. Then comes incomplete circuits, which are otherwise called as open circuits. As you can see over here, a conducting wire is missing, which connects from the positive terminal to the other end of the light bulb, the other terminal of the light bulb. So the bulb is not going to glow. Over here, the second scenario, the source of electricity, the bulb with the battery itself is missing, and therefore again it's an open circuit and the bulb will not glow. Let's take a look at the circuit diagrams for the open circuit and a closed circuit. For the open circuit and a circuit in which there are 2 batteries arranged in series. So this is how one would look. And here you can see that there are 2 cells arranged in series as well as 2 light bulbs arranged in series. Switches or keys are used to make or break an electric circuit. You are all familiar with switches, which are used to control our devices, right? To either turn on or turn off the devices. What do? They can either complete or make the circuit closed, or they can open and make the circuit incomplete. These are the circuit diagrams for the switches.